So today we have Jonas Iggbom from Axiomatics. He's the VP of Sales Engineering in North America with over 20 years of experience in product management and technical sales in endpoint security and access control. His expertise lies in encryption technologies, keys, certificates, and SSH, as well as access control solutions for privileged and end user accounts, databases, and applications. And our guest expert is Carlos Garcia, Senior Principal Architect at Optum in the Office of the CIO. He brings over 20 years of experience working on identity and access management systems, the majority of that time at Optum and United Health Group. His expertise is in the architecture and operation of large-scale identity providers for enterprise, customers, and providers. Having spent most of his career in operations, he brings a perspective on systems design rooted in the impact of design decisions on the way systems perform and scale. So you are in good hands with these two experts. So Jonas, I'll turn it over to you to kick off the session.
All right, thanks for that introduction, Kelly. Happy to be here. Yeah, so I think we got to an interesting topic. Carlos and I have been working on this very topic together for a while now. I'm obviously mostly focused on the authorization parts, and Carlos brings his expertise on Kong as it relates to this topic, but Carlos also has a breadth of experience with authorization and ABAC in specific. So I'll start off with covering some of the characteristics when we talk about attribute-based access control, and we'll sort of, I think, have an interesting conversation back and forth here a little bit on how we can apply authorization to APIs, specifically in a Kong world, and a little bit more flavor towards the healthcare industry, since that's where Carlos brings a lot of expertise from. When we do talk about attribute-based access control, or ABAC in short, we have a lot of building blocks that we can leverage to determine authorization. This is a highlight here of sort of the different categories that we can use as input to determine access, essentially. And in a traditional authorization model that I'm sure a lot of you are familiar with, which would be role-based access control, you essentially only have a role. But for attribute-based access control, we can leverage different attributes or inputs or metadata or whatever you want to call it to get to an authorization decision. So it's around who you are, what you're trying to get access to, when, where, why, and how, for example. And there are different things that would go into these buckets. Obviously, the who is not only the user, it could be the role, the cost center, and things like that. So we still deal with roles, but in an ABAC world, a role is just another attribute, just like the cost center you belong to, the region that you're in, for example. And Carlos, if you move to the next slide here, we'll look at some of the more detailed characteristics of attribute-based access control. In a great extent, we talk about this as being externalized access control too. In fact, I think that's what the label that Gartner puts on this too. And the fact of externalization comes from that you usually have an externalized authorization engine that can be leveraged by a lot of different components, be an API gateway like Kong, but it could also be your application or something like that. So the point here is that you externalize the authorization logic from the business logic, and the business logic and sort of application developers, for example, can focus on building and developing the best application, and they don't have to spend their time and focus on building in access control into the application or into the business logic or the APIs, for example. The fact that you extract this out also usually means that you have a centralized authorization engine that can be leveraged by multiple different application APIs, leveraged at different tiers within your application. And you get one centralized point that you can maintain and upkeep and control the policies within. So you don't have to deploy or change access control logic in multiple different places. The other aspect of that is you centralize a point for audit purposes as well. If you want to understand who can access what under what circumstances, you can actually look at the centralized authorization engine for that instead of potentially looking at tens or hundreds of different applications. In our case, it's standardized. We at Axiomatics build our solutions on top of the XACML or XACML standard. So it comes with a standardized request and response schema, as well as a standardized policy language, which we're not going to cover in depth today, but there are different ways of authoring these XACML policies. But the fact that it's a standardized policy language is obviously powerful. It's flexible in the sense that it can be applied to a lot of different things. We'll talk a little bit more specific healthcare and API use cases here, but you can author policies and implement ABAC for APIs directly within applications, databases, you name it, and use cases span from different types of verticals, healthcare, financial, but you can also have access policies that control access into a room, for example, if you hook in the authorization engine to the physical access control of a door. Dynamic access control is another commonly used term for this, and the dynamic aspect of this is the fact that you have a fairly static policy, but attributes tend to change, attribute data tend to change, and when they do, access will change, right? So what happens from a runtime perspective is that the policy is combined with the attributes to determine essentially an entitlement. It's dynamically calculating an entitlement at runtime based on the policy and the attributes. And if the attribute has changed, you might see a different result out of that. But the attributes would change anyways. It's sort of irrelevant from an access perspective, to be honest. If a user is moved from one cost center to another, that's something that happens within the HR system. And that will change the access that user potentially have, right? So the access is dynamic at runtime, and it's mostly due to the fact that attributes change, not necessarily that the policy changes. It's context-based and risk-based, where we can leverage sort of contextual input and risk scores and things like that, for example, to determine the decision as well. So those fall in the bucket of being inputs and being attributes that are leveraged at runtime in combination with the policy. So there's a lot of different components within the entire ecosystem around authorization. I kind of wanted to highlight sort of the topic we're talking about here today is mostly focused on API gateways, and we are talking mostly specifically about Kong today, but there are several API gateways that we at Axiomatics have integrated with along with our customers. But I wouldn't say that the ones listed here are sort of exclusive and these are the only ones that it's possible to work with. In general, the principle is the same for all API gateways in terms of how you would inject authorization into the API flow. They all work a little bit different. They have their own some have out-of-the-box capabilities. Some you have to write a small plugin. So they all work a little bit different, but the concept of how to do it is the same for all. In the Kong case, and Carlos will cover this a little bit more, we have a plugin that is written for Kong specifically. If we talk about Kong from sort of a high level perspective, we have seen an uptick in sort of requests for integration with Kong over the last 6 to 12 months. Before that, I don't think we heard much of it at all. Now it's becoming more prevalent in requests from our customers and prospects at Axiomatics. It's a very, very lightweight and easy to work with API gateway that is, extensible through Lua scripting, and that's essentially how the integration has been done here. It's an open source API gateway with a very active community, and Carlos, you can probably talk more to that because you are heavily involved in that active community as well, right?
Right, yes. It's a platform that we selected because it already had an active community, and for all the reasons that we're going over now and that we'll get into more detail with. And yes, as part of our commitment to open source, we want to also give back to the community and contribute. So yeah, if you go to Kong's website and look at some of the plugins, you'll see that Optum has quite a few out there, and we continue to build new plugins, including the ones that we'll talk about today. Right.
Yeah, it's very cool, and we'll look at we'll highlight some of the plugins towards the end of this webinar as well. So if we look at some of the common use cases for APIs, if we look sort of at it from a high level and look at an architecture and what it can look like, this is a fairly generic slide that just says API gateway. From an authorization, an ABAC, and more specifically an XACML or XACML architectural perspective, this is sort of the baseline architecture. The API gateway here operates as a policy enforcement point, or PEP, as we call it. And the APS box here is the authorization engine. So you essentially have the API gateway intercepting an API call to a backend API. And how it's doing that, we'll talk a little bit more about, but that differs a little bit between the different gateways. Essentially, what has to happen is the gateway needs to make an external call out to the authorization engine. And in this case, it's in the example here, it's saying, can the client call API X method Y, for example? This could obviously take many different shapes and forms that we look at later, but an authorization request is then sent to the authorization engine that applies the policy. It can, if it needs to, look up additional attributes in order to make the decision. And this is step number 4 here, can be done from essentially any data source. There's several supported out of the box from our perspective, but you can also custom develop a simple connector to any type of underlying data source that holds the data. And combined with the attribute data that's coming in from number 2, the request, as well as the attributes that are coming from number 4, the authorization engine will apply that to the policy and get to a decision. It's going to return the decision to the API gateway. In the simplest form, this is a permit or a deny, essentially yes or no. Is access allowed or is access not allowed? The gateway handles that decision, and if it's deny, it probably turns around right there, so you won't have step 6, 7, and 8, for example. You will jump straight to 8 that says access is denied back to the caller, the application. If the decision is permit, the API gateway can continue and forward the API call to the backend API, and after that it could be business as usual, so to speak. The information is returned back to the caller. There are a couple of simple sort of use cases here. Obviously, you can control access to the API as such. It could be on a user basis, application, client, whoever is called. You can authorize whoever is calling the API. I usually talk about this as sort of it's sort of a, when we talk about ABAC, we usually talk about fine-grained access control. And if you're only authorizing the API as such, you know, the records API or the medical records API or transaction API or whatever it might be, it's a fairly coarse-grained access that you're controlling. But there could be a very fine-grained policy behind the scenes that's controlling that coarse-grained access. So it's sort of on the principle of securing the API at multiple sort of layers. That could be your first step of authorization, right? That the medical records API cannot be executed by users without a specific role or from a specific location or from a specific application or something like that. Then you can jump into a little bit more fine-grained where you talk about having policies and controlling access to specific resources. And that could be, you know, a user is trying to view medical record 1, 2, 3 or something like that. Now we're down to, it's a little bit more fine-grained. Well, it could be a fine-grained policy, but also more fine-grained access control. I added the get, post, put because those are sort of easily understandable building blocks for something that you can control access for, right? So you can have an exposed API that exposes several methods, but there are actually different policies in place to control if a user, an application, or a client is allowed to do a post or a put, for example. For certain APIs, they might only be allowed to run a get or execute a get. I think, Carlos, you had some more specific examples of this and a little bit more sort of flavored towards the healthcare and the patient.
Right. Yeah, and the kind of use cases that we came across where we looked to implement the fine-grained authorization rules and of course the Axiomatics solution, came across a lot of our medical APIs where we're looking at test results, records, patient records, or test ordering type APIs. And the notion being that, yes, well, some APIs, that kind of coarse grain, that middle, kind of like a middle layer of authorization is appropriate, where you can get a record, but you can't, you know, make changes. You can't do a put to it or a post to it to modify it. And if it's an API it's okay. You don't need fine grain. You still at least have that coarse grain around it. But it really gets down to, in our examples, making sure that, you know, clinicians, you know, such as, let's say myself as a clinician, I'm only allowed to see the patients that would be under my care. Perhaps it could be multi clinician in the sense that, you know, there's a doctor and I am the doctor's nurse, and together we have a bunch of patients that are under our care. And so having that relationship that says, you know, I'm able to look at patient records through this, you know, central API that's going to give me access to all the patients, but to make sure that when I look up a particular patient record within the back-end entitlement system or the system of record for that, we're able to validate that, yes, that is a patient that I should be able to see because I have a relationship with them. And so the way we look at it is, as I was mentioning, is we have, we'll get into more details of what these plugins are, but within the Kong gateway, we have the notion of an authentication plugin that does, you know, takes that authentication token, if you will. And from the claims, it's able to say, well, based on my role as a clinician, I do have the ability to make requests to that API. But by having this additional, Axiomatics plugin, it also takes those claims and within the policy rules knows to look at the back-end system where the attributes are for that patient record to make sure that indeed the attributes exist that would show that I have a relationship with the record I'm looking up in order to do an approve or deny.
Right, and I think that it's a very common sort of scenario that you mentioned there. Although this is a specific scenario to sort of patient records and the relationship between the clinician and the patient, for example. But that part is something that we see over and over and over again that ABAC is used to solve, and it's impossible to solve with just pure role-based access control, right? And that small little part is very, very simple to express in ABAC. And what I'm talking about is the relational type of use case. In this case, it's sort of a relation between the clinician and the patient, but you could have segregation of duty cases where you cannot approve a purchase order that you created yourself. That's another sort of, it's a relationship between me and the user and the purchase order. So and they could be, we have seen insurance type of scenarios where you can only work on insurance cases in your own region and things like that. So that's a very, very common scenario, the relational type of aspect from a policy.
Right, and to add on to what you just said, exactly, some of our use cases get into a clinician that should only see patients within that hospital. As with many, clinicians, they'll work at different hospitals, and while you might have access to patients at one, there's no reason you should be trying to look up their records when you're at a different location. If that's the type of location where you start bringing into some of that, the context around where you are and what you're trying to do and when you're trying to do it,
exactly.
To add further fine-grained security.
Yep, definitely. And we see that also, one sort of use case that ties into that and maybe more frequently in healthcare than I've seen anywhere else is sort of the break the glass concept, because even though you're not supposed to view patient records of patients that are not yours, there could be a matter of life and death in a situation. So you could do things like that from a policy perspective too, that okay, you're not really allowed to do this, but I will let you view this record, but we are going to log this and report this and flag this everywhere so that that now you're doing something you're not supposed to do and you are being watched, but if it's a matter of life and death, you should still be able to view that patient record, for example. So there's a lot of different aspects that could go into the policy and the mechanism around it.
Right. And that you're right, absolutely right. That's actually one of the other use cases we have come across that was a big concern in the beginning. And so kind of we went through this model where that ability to do break glass is kind of built into, this process, this solution. Because yes, you'll have the doctors who maybe for whether emergencies or also for interpretation of being one doctor's like, I need to see this because it's similar to what my patient is. And so I'm going to look at a record for comparison. And that's a legitimate use case, but it's not one that you'd want to see too common. So exactly, just the ability to do it on demand as needed, but have an audit of it to make sure you don't see an abuse of that.
Yeah, exactly. So those are interesting use cases, and they're fairly sort of common in different variations. I have talked about the topic that we're looking at here as well in a different webinar, more sort of targeted on a different API gateway, but the principle is the same. I just wanted to highlight it here that there is the aspect of performing sort of, we can almost call it a secondary authorization or authorization on the way out. So the first part in what we've talked about up until now is sort of controlling access to, in this case, record with the ID 123. Is that allowed? Can this application or user perform a get on record 123? That's the first authorization. If that's yes, that's fine. we will fetch record 1, 2, 3 from the backend API. But that's where we can do additional authorization on the payload itself. We can then control and see, okay, so in record 1, 2, 3, what are the fields that this user or this application should be allowed access to or should be able to see? And that's sort of an authorization we can perform on the way out to apply sort of a filter or redaction of data within the payload. So now we're getting very fine-grained in what we're authorizing. We're authorizing specific individual fields in the payload. There's a lot of different technologies of doing that I'm not going to deep dive into here, but just wanted to highlight it is possible to redact and mask in different ways the payload. And so we can have a specific part of the policy that controls access to the specific field. So you essentially have a policy on the amount field of a record, for example. We're not going to look at that in detail. I just wanted to mention that this is also a fairly commonly talked about use case for API gateways in general. So let's talk about a little bit more about Kong in specific. Carlos, I'll let you talk about that since you have the most experience with it.
Right. So Kong, as we described it, it's a open source API gateway. So think of it as equivalent to a layer 7 gateway or a data power Axway. Except it's extremely lightweight. It's very small. It can be deployed as a Docker container. It's very lightweight and scalable, very simple. It's built on Nginx, and it's very high performance. Obviously, by being open source, it's, the cost of ownership is extremely low. The simplicity of the administration, I would say, lowers the cost of support of it. And our own internal testing has shown an average of 65% performance advantage over our legacy layer 7 environment. So it's extremely fast and cheap. The plugin architecture is really great because it does allow for the notion of building your flows, if you will, like when you proxy an API, what are the different type of interactions you want to apply to the request response. So everything from authentication, bot detection, transformation, logging, and some monitoring stuff, you can add them as required by your APIs. From a kind of high-level architecture, the Kong gateway is deployed in whatever format you'd like. We like to deploy it in containers. It uses a backend database kind of for its configuration store. So we also use Postgres SQL, which is also an open source database. There's this Conga UI. It is an open source UI that talks to the API gateway through an admin API port. And essentially, at a high level, you proxy your backend microservices. And in the front end, you're able to create a route or multiple routes, if you will, that forward traffic to those microservices. This is kind of the Conga UI to give you an idea of what it actually looks like. On the left side, you see there's, we're looking at the dashboard, which is really similar to kind of the info screen. It'll show you all the plugins that you have enabled and a subset of which ones are actually in use. Services would be the APIs themselves that you've proxied. And routes are essentially that, the routes of, how do I take incoming requests? What are the exposed URLs that I'm going to forward onto the backend services? This is what the definition of a service looks like. In this case, it's the admin API that we have configured. The admin API is great for automation. We tend to have Kong Gateway as part of our CI/CD pipeline. So as new microservices are brought up, through that process, we hit the API and dynamically create new proxies to those microservices, as well as the plugins for authentication requirements and so forth. So the plugins, kind of a high level what a plugin looks like, or the architecture behind it, is essentially at that that route where you have that exposed URL that forwards to your backend API. You're able to add these plugins. They have a priority about them, so you can set them up with, especially their custom plugins, what the priority level will be for them. But in the sense of what we've been doing, we, have the authentication first, followed by authorization, followed by, rate limiting and logging, in order to kind of go through these different plugins before you get to the actual microservice. This is kind of screenshots of what some of the plugins look like. You have the ability to do both global and local plugins, in the sense that, on a global level, I would enable the logging. So all my APIs, I'm going to want logging for all of them. I'm going to want bot detection for all of them. So those plugins, I'm able to enable them at that kind of global level, so they're automatic. But some of the authentication, because depending on how I'm doing authentication, or if it's some sort of custom transformation, I'm able to add those specifically to the proxies that I'm putting together. So with that, we're going to do a demo. So I'm going to kind of switch. In order to make sure this would work, I did pre-record a demo. And in this, the background is kind of the use case we described. We're going to have, we use Azure as the IDP. And so as one of our plugins, we actually do the authentication and then pass the claims information to the Kong Axiomatics Authorization plugin. So this is kind of more from a developer point of view, so you can get an idea of what the flows look like. But in this case, we're using bScepter to mock an API in the back end. Highlighting right here is the resource that we're trying to get access to. And so we have both an approved identity, and we also have one that doesn't have the relationship with it. So we'll show you kind of both flows so you could see what it would look like when you're trying to authenticate to that backend service. But you one, have a valid relationship, and two, you don't. What is the kind of the differences you're going to see? So on the back end, we have basically a database where we have this notion of a referral UID and a clinician UID. So the clinician is basically the part of the identity that's coming from the identity token that we got from the OIDC authentication with Azure. And so in this case, we have this clinician who must have a relationship with this referral in order to get access to it. So here's an example of what the JWT looks like. And so you can see it matches with the clinician. So that if you're that individual, you would have access to that referral UID. The referral UID is the record you're trying to request in your GET. And so the use case would be that you're coming in to look for a patient record, a referral record, and that's the value you enter. And so the policy is going to be such that it's going to look at that clinician UID and be like, well, do you match this? Do you have access to do this? And if you do, then you'll get the approval. And if you don't, then you'll obviously get the deny. So here, 1 second, and we will go to run it. I will add that this little demo video, we will show it. We will have it uploaded in the with the link in the GitHub repository to this plugin, so you could see the full video, because it's a longer than time allows right here, but it gets into a lot of specifics on both the Kong setup of the plugin as well as the action of it. So here, let's go to actually getting the JWT. So we're going to show what happens when you do a direct call. And in this case, you don't have the JWT. So you get, there's no authorization. And so that's the plugin saying that, you fail, there is no authorization header present. So we're going to reject this completely. Now the next part of it will be to, okay, fine, let me get the correct JWT. I'll copy the bearer token and actually add it as part of it to see what we would get. Here, a little timeout error. Let's try this again. And so in this case, you get the response that you expected, which is the referral ID and some just, some secret information that is returned from that. So that's the case of a success. In a bit, we'll get into looking at the backend logs to show you what it looks like from the Kong point of view. In this case, you send a request where you're not, you don't have a relationship with the backend database. So in this case, you get the deny. You get the request was not authorized by the PDP. So one of the things is that in regards to how we define the policy is that the way you define the policy in this case is extremely simple. Does Carlos, the individual, have access to look at this record? The complexity of the policies you can create really come down to, all the identity claims that you're able to get. So with the OIDC, your identity token, you're able to get various pieces of information about who you are, your location perhaps, the different roles you have access to, and you're able to leverage all of those in combination with some additional attribute providers, which could be backend databases used by the APIs in order to define your policies. So in this case, we're rerunning the test, this time with the logging in the background, so we can kind of show what it looks like. So this is an example, like, okay, great, it's not authorized. And so if we look at the logging, you'll see that, the post was sent to the PDP. It was rejected. It looked, here's the value of the OID. And in addition, there's other things like there's the value of the referral UID, the request you're making. And because there was not a relationship there, you got the deny, essentially. Now, this is where, as I was mentioning, you'll see that there's an attribute for groups, and those are some of the group values. Any claim information, you can add it to the plugin to say that these are the various pieces of claim information that are going to be part of the policy. So please add them at the time, when the post is done to the PDP. Here's again the example of how they match with the JOT. And there's the referral UID, the request that was not present in the relationship. So lastly, what we'll do next is to show essentially the same thing, but with the valid JOT. There we go. There we go. We get the success, the permit, and again, looking at the logs, you're able to see that in this case, the OID, which maps to the clinician UID in the database relationship with the referral, matched, and so you got the permit. I'll pause the demo there and we'll come back to this. So how the architecture around that looks is, as I said, we have the Kong API gateway with the plugin deployed within, in our example, we used OpenShift. And so it's just a flavor of Kubernetes with some additional features. And we have all of our microservices deployed within a namespace. So the Axiomatics Access Decision Service, which is also a nice lightweight microservice, so it's deployed within the same namespace. So when a request comes into the API gateway to get to that patient record backend API, the plugins kick in, and as I mentioned, we have at first an OIDC plugin that does the initial authentication, gets us our identity claims information, and passes that on to the Axiomatics plugin, which then forms the request and does a post to the Access Decision Service API. The Access Decision Service, within its policy, also knows that, hey, I need to look at this database to validate that the relationship is valid. So it does that lookup and then returns the permit or deny to the plugin, at which the gateway can then either allow the traffic to continue or to reject it. Similar on Kubernetes, I don't know if Jonas is something you want to touch upon, but it's very similar to the deployment on OpenShift.
It is very similar, right? I mean, I think we have a pretty decent blog post on how to get it running in Kubernetes, and if I remember correctly, we shared it with you, and you were pretty much able to translate it into how to get it
absolutely
on OpenShift in an easy way too. But in principle, what we're talking about there for ADS, the Access Decision Service, is it's another form factor of a PDP that is extremely lightweight and fits well within sort of this architecture, especially in conjunction with Kong. As you mentioned, you can run all of it in the same environment, right? You don't have this thicker, more heavy to work with PDP that runs somewhere else. The Access Decision Service it's essentially a jar that needs to be executed, but it also, just like Kong, fits extremely well to containerize, right? So you have a containerized authorization engine that sits behind a load balancer for the authorization purposes, and we've done sort of the Kubernetes blog post that we have also discusses, I think it touches on the discussion of auto scaling this entire environment, right? So you have multiple instances behind a load balancer where you can monitor the load balancer for whatever metric you want, and then auto scale additional instances to kind of cover peak loads or things like that.
Right. And in addition, I mean, the way that we define policy, we are currently still using the kind of the UI ASM to create the fine-grained policy, but then we export it. And if you're familiar with Kubernetes or OpenShift, the whole notion of a config map, where through our automation, we're able to take policy, extract it, and basically push it out as a config map within a Kubernetes or an OpenShift environment, so that the microservice itself, every time it restarts, it's able to pick the new policy. So again, this is the notion where you're not redeploying an application. You're able to separate policy out from the microservice so you can dynamically update it so it's not tied to any sort of release. And at the end of the day, that's also part of the notion of externalizing the authorization rules for development teams who are focused on their microservices and saying, the story for externalizing fine grain comes down to, you want to be able to not worry about changes in policy, changes in business or security rules that kind of bleed into the development of your microservices and having to take them into consideration, whereas you can kind of have it externalized so that it's handled at the gateway as much as it can. And again, this is a microservice, so in some use cases where there is an API that needs to do a lookup directly to the Axiomatics Access Decision Service, it's still able to. I mean, it's at the end of the day, it's still a microservice itself that's able to give decisions to not just Kong, but to a microservice going to it directly. So it's just a screenshot on an OpenShift for those that are familiar with it. And in this case, I have even the ASM, the Axiomatic Service Manager, running as a pod. That's a little bigger. It's not quite a microservice, but the notion being that we're able to run things within the containerized environment, and it's been working really nice for us. So I think in summary, I'll start with, I mean, Kong we're big fans of Kong. It's really easy from an administration point of view, and of course the cost of it. And we like the ability to control a lot of the features that we need, and especially with the community that, we pass back the plugins that we've created, and as well as others have. And so it's a nice community where we are able to solve a lot of things quicker. So the fine-grained authorization for APIs, it gives us again the ability to externalize that from the developers, and so we manage as much of it as we can from the gateway. And of course, it's not going to account for every possible use case, but where it makes sense, where we're able to do it, it certainly simplifies the design, since all traffic has to go through the gateway in our case anyway. And again, that allows us to kind of have that global view of our policies and the audit around it, and to make changes centrally without having to worry about requiring deployments and impact on any business functionality because of a security change. Jonas, you want to add to that?
Yeah, I mean, and then from a summary perspective, we follow sort of the traditional characteristics of ABAC and applying sort of ABAC, attribute-based access control, to APIs in general, right? So it is the characteristics of externalizing it, centralizing it, and leveraging a policy-based approach for it. And although that's not something that I think you have implemented yet, but we did also talk about the masking,
right,
and or redacting, which is possible, and I think it's becoming sort of more and more interest around that as well, and how to do that.
It is. I mean, we're definitely not done developing our plugin. I think we're at a point where we've done a good amount to get started and get functionality of it. But you're right. The notion of obligations or kind of redacting some of that is part of our plugin roadmap.
Exactly. So if we look at some of the next parts here, these are some of the plugins that are already available, right? The one we've talked most about here is the one in the middle here, the Axiomatics Kong plugin. But there are others, right? Available. These are probably some of the more common ones, but there's more than this for sure as well.
Absolutely. Yeah, these are all Optum kind of created in some aspect. Some of them have gone through our process that they're showcased on our Optum GitHub page, and the other ones have kind of send you the links for those that have been the main developer creating them. So they're not quite available at the Optum GitHub yet. But like I said, we like to create these plugins. We think it's a great framework. So people are more than welcome to look at them and try them out.
And a couple more plugs here before we get into the questions at the end. So the next webinar from an Axiomatics perspective is with a partner, IDF Connect, where we talk about similar topic, but not exactly the same, but it's cloud first, looking at APIs and single sign-on authentication and authorization and in a cloud first sort of approach. So don't miss that. We have a link here for sign up. It's on July 10th. And then if we move to the next slide, there's, if you have any initiatives around what we've talked about here, I'm happy to talk about it further from an authorization perspective around APIs. I'm sure Carlos is happy to take sort of further conversations more specifically around Kong and things like that. We don't only work with Kong, we also work with Apigee and other gateways. Let's take a look the last couple of minutes that we have here on some of the questions that have come in. So I have, let me pull them up here. There was a question earlier, and I think it was essentially answered towards the end here. Does Kong only work with a cloud native PDP, which is the terminology or the actual name of this access decision service that you have been using here, Carlos? And the answer to that question is no, it doesn't only work with that type of PDP. It actually works with any PDP that sort of follows the XACML standard. To be honest, in our case, there's a specific format of the API that the authorization request is sent to, but since it's built on top of the XACML standard, it actually works with a PDP that follows the standard. So from an Axiomatics perspective, we have basically two form factors of the PDP, but they both expose the same type of endpoint, and they both accept the same type of request. So yeah, you can use the cloud native PDP, but you can also use the sort of the traditional, we could call it thicker PDP that's, from our perspective, deployed as a web application into a web container, or an application container.
And early on, I actually did deploy it as a container, both that one and the ASM. So
that's right.
Yeah, so you're able to do that. And if anybody ever has OpenShift questions in regards to how we got it done, please feel free to reach out to me as well.
Right. I have a question. If the PDP is available as a Docker image, it's not. I want to say yet. I'm trying to work towards that, but we can, at Axiomatics, we can provide you a Docker file so that you can build the PDP as a Docker image. When it comes to the cloud native PDP that you have been using, Carlos, the purest way of Dockerizing that would probably be a Docker file that contains not much more than 2 or 3 lines,
right?
Something like that. It's
and honestly, I think at the end of the day, you tend to want to, the Docker file for me, I think, is better than an actual Docker image, because you'll always make some changes, whether it's, APM plugins that you put in or whatever it might be. There's very few native Docker images I find myself ever using. It's generally like, oh, great, a Docker file, and I could modify as required to run within my environment.
Right. Yeah, I agree, except for these sort of baseline images where you have sort of the pure OS, or like the OS with Tomcat, or OS with Java or something like that. There's always some kind of tweak or modification you want to make anyways, right?
Mm-hmm.
So another question that came in a little bit earlier: when defining policies, an integration with the pip should allow the definition of a value type supported by the pip. Is this correct? So when you define a policy, it's actually related to another question too. How do you write the policy? So when you define a policy, there's two, from an Axiomatics perspective, there's essentially two, you can almost call it 3 different ways of authoring a policy. You can use the UI that you mentioned, Carlos, ASM, the management system that has a web UI to write policies. We also have what's called a plugin for Eclipse, the Eclipse, the IDE, that allows you to write policies using the standardized alpha syntax. So it's more like it's almost like a programming language to author the policies. That is the policy that's in place and used. It's loaded in memory in the authorization engine that it uses to answer authorization requests. A pip is the connection that the authorization engine, that the PDP has to underlying data sources to get attributes. And if you have sort of the relational scenario that Carlos and I discussed earlier, that you can only view a specific record that's in the same region as yourself, then probably in the request you're passing the key values, right? You're passing the user ID and you're passing the record ID, for example. Then the policy says if the record location and the user location are the same, you get a permit decision. And so when the PDP gets to that point in the policy, it's gonna look to see, do I know what the record location is? Do I know what the user location is? And if it doesn't, that's when it will invoke the PIP or the attribute connector to get those attribute values from the underlying data sources. And if they match, you know, in our hypothetical scenario there, you get a permit decision. Another question that it's tricky to answer, but we'll try. What is the latency cost when you apply this model to an API request? And in a sort of from a highly performant mission critical scenario, for example, in telecommunications, it's hard to answer because there's a lot of factors that go into what the latency would be. From a pure sort of internal perspective, the authorization engine can handle a lot. So the latency there would be, you know, down to the nanoseconds. But what we can't control, and the reason it makes it tricky to answer what the exact number would be, is part of what we just talked about. We don't know, and we can't say for every scenario what the cost of looking up an attribute from a PIP perspective would be. What's the latency in the network there? Where is that service? How fast is that service to respond, etc. So one piece there that impacts that is the fact that the authorization engine can cache attribute values internally. So that's a configuration that you can make. I don't know if you have any perspectives on what you see on sort of performance in the work that you've done so far, Carlos, and in specifically in relations to Kong and you know.
Sure. Yeah, I don't have any really good stories in regards to what we've seen. I mean, it was a big concern, and that's part of the reason we actually liked this solution, because we're able to run the microservice within the same namespace. So in that aspect, when we do the traffic, you know, when you do the request, you're not stepping out of the call it the namespace, or I guess we're the OpenShift project. So the traffic never gets out. It's all, you know, inter-container communication essentially.
Yeah.
And so that definitely we feel is extremely fast. But from the point of view of doing, you know, massive load tests to do a compare with and without, you know, we haven't seen performance issues. We'll start with that, but we haven't done any sort of test to show with or without to come to a number of what the increase of impact is.
Right. We, in general at Axiomatics, regardless of Kong or microservices or how we typically see sort of down to single-digit millisecond latencies. We have some deployments with, you know, hundreds of millions of users using the system. We also have deployments within sort of financial situations where we have seen up to around 20,000 requests per second being handled from an overall perspective and overall architecture perspective. But in your case, Carlos, I think you have sort of co-located all the components to make the best possible situation, right? So the latency between the, you know, between Kong and the PDP is extremely low. And if you also have the data source within there, then, you know, you've done what you can to reduce latency and the impact of that.
Exactly.
Yeah. All right, we're actually a couple minutes over, so I think we'll stop there, and we have a few more questions, but we'll try to answer those individually back to the people that that asked them. I think that concludes our session today. Thanks very much, Carlos, for joining in for the insights from a Kong and you know, the healthcare perspective.
You bet, my pleasure.
Thanks all, and have a good day.